Hi everyone! In this video, you will learn how to implement a simple circuit on the breadboard.
All right, now that I have this breadboard, what's the next step? The next step is getting my components. What do I need? I need the resistor. You see here, we got the resistor. It's gonna ask you to write the value. So let's say 100 ohm. So let's just make up any circuit. I'm gonna put this resistor here. And notice if I put it here, is it correct or wrong? So the view here is what? On your board, it's like this. Is this correct? What did we say last time about the 5 dots? Same node, right? So what am I doing here? You're connecting the resistor to itself. What can I do? I can either do this, because remember this separates those 5 dots from those 5 dots. These 5 dots are what? A node, and this is a different node. Okay, so in this way, this resistor here, this is a node, and this is another node. It's not connected to itself. So this is correct. I can also do what? Click on the resistor and rotate. And maybe I want it to be in the same side like this. It's still correct. Why? Because this is a unique node and this is a unique node. Okay? Let's say I want 2 resistors to be in parallel with this resistor. What do I do? I get another resistor. And let's say I put it here. In your breadboard, you have the flexibility to control the length of or the extension of the legs of the resistor. Here on this simulation, I don't have, but that doesn't mean that I cannot have flexibility. Now I have this resistor, which is 1K, and then I add another resistor in series with it. Those 2 resistors, I want them to be in parallel with this resistor, okay? Now those 2 are in series. Why? Because they share one node. Here, this node is being shared between R2 and R3. Let's change the value, let's say 500 ohm. Okay? Now, for those 2 to be in parallel with this one, what do I need to do? Okay, from where? From this side or from the first dot? Yes. This way now, those 2 resistors are sharing one node with R1. What do I need to do now? From R3 to R1, from here? From here, right? Now those 2 resistors are in parallel with this resistor. How does it look in drawing? If you draw it, this will be something like this. I have R2 and R3. They are in series, and they are both in parallel with R1. Okay? Now, for example, maybe I need to connect a battery like this. And let's say it's 1 volt. In this simulation here, it will allow me to have a battery with a plus side and a negative side. On your breadboard, you will have what? You will have to connect the plus side with this node here. For example, on the breadboard, you have 5 volts or 15 volts, right? If I wanted any other value between that, or from, let's say, from 1 to 12, I can get it from something called VPS, variable power supply. It's denoted by supply plus and minus. Here, supply plus ground, and then supply minus. And then on the side, you see there it's written variable power supplies, right? So you put, instead of, where is it? So instead of this node, let's call it node 1, instead of being connected to 1 volt, to 5 volts, it will be connected to the supply plus. And then from the software, I'll show you the software. From the software, you can choose what is the variable of the voltage that you require. Now, this side, let's call this, if this is node 1, this is node 2, and this is node 3. Node 3 here will be connected to the ground. On this simulation here, let's go back. What do? I'm going to search for a battery. So let's just use 1.5. For the battery, I can just simply connect plus, and then the minus is connected to what? To here. How can I make use of these columns here? Remember what we said last time? That one of them is the plus and the other is the minus. What I can do is I can delete this length, the plus connected here, the minus connected to the other. And in this way, in connecting the plus here, I'm connecting, look at this, I'm connecting the whole column. Now what do? You connect from here to whatever you want. Now my circuit is ready. It's complete. To measure the current, what do? I need a multimeter or an ammeter, and if I wanted the voltage, I get the voltmeter. But in here, we have a multimeter. Let's zoom out. This is the multimeter. On the multimeter, you can choose what you wanted to do. For example, I wanted to measure the current, right? So I changed the option to amperage. If I wanted the voltage, resistance. How did we do that in the DMM? What did we do? We connected COM to banana B, and then if I wanted to measure the voltage, I'm going to connect this here, the V and ohm, to what? To banana A. And then I'm going to take the bananas from where? From this side here to whatever in the circuit. And remember, the bananas are for measurement. They're not providing voltage. They're not providing current. They're just wires connected to the DMM. Now, I want to measure the current that is going through this branch here. I want this current. Let's call it I2. So, as we did in the simulation, we need to insert the ammeter here. We can insert the ammeter in series with R2 and R3. How do we do that? Like this. So this connection is correct for something else, not for current. For voltage across those two resistors. But if I want to make it in series, it means it needs to share one node. So how do I do that? I'm going to delete this wire. Now I'm going to delete either this wire or move the resistor. I need to break the circuit. I need to break it either here. So where can I break it? I can break it here, or after R2, or after R3. And after I break, remember I have this DMM, which has two nodes. One is banana A, and one is banana B. So if I broke the circuit here, let's break it. If I broke it here, remember all of this was node 1. What do I have now? This is node 1. And then I have a new node here, right? This is node, let's call it 3. No, we have 3. Let's call it 4. Are you with me? Do you agree that this is a new node now? Because I broke the connection, right? I took this wire away, or I took the leg of this resistor somewhere else. So this created a gap in the circuit. Now I can put my DMM in this gap. So it's gonna be like, if this was my DMM, one leg will be with the wire, which is either banana A or banana B. It doesn't matter because it only affects what? Direction, the sign. But the value will still be the same, and this is banana B or A. To measure the current, I need to put it in series. Series meaning it's sharing one node with either R2 or R3. Okay? If I don't want to break it here, if I want it in between the two resistors, what do? I'm gonna make a break here. Then this will be 2. Now this is 2. This is node 2. This is 3. And now this is a new node because there's a break, right? This is our node 2. And this is a new node, call it 4. Now the DMM to be in series, it will be like this. This is the DMM, one leg here and another one here. Let's apply it in this simulation. I want it in series, so I want to break it, let's say here, because we discussed breaking it here, we discussed breaking it here. Let's discuss breaking it at R3. So what I'm going to do is I'm going to just rotate it a bit. Okay, rotating it, you don't have flexibility. So let's just say it's like this. I'm going to break it by changing this wire to another node. Let's drag this wire further down. You see now I created what? A gap. R3 now is no longer connected to R1 from this node. What do? I'm just going to insert one wire here and one wire here. So one wire at the old place and one in the new. Now let's see if I run the simulation. 995 microampere. This is the current in R2 and R3. Okay? Let's break it in another place. Now I measured this current. I'll delete the wires, or in your case, remove the wires. And after I remove the wires, I put back the circuit the way it was. Okay? This is an important note for your circuit. Now you made a break to insert the ammeter. I finished reading this current. Maybe I want to read something else, a current here. Okay, what do? I return the old connection and then I break it somewhere else. Let's say I want to insert it here between the two resistors. I'm just going to move this. You have more flexibility on the breadboard that you have, more than the flexibility I have. What did? I broke this connection between R2 and R3. And then I don't care which leg of the DMM. I'm just connecting one here and one there. If I got the value in minus, it means that the direction of the current is reversed. It's not the same as the direction that I assumed. Look, the current is going this way, but I connected the minus here and the plus here. Instead of plus and minus, it only affects direction. So again, let's discuss series and parallel. If you have questions, please ask now. For two resistors to be in series, they share one node like this. Okay, in between them, there is one connection. If they are in parallel, they would be like this. They will be sharing two connections together, like this. This is one node, and this is the other. Those 5 points are one node. Okay? These 5 points are not connected to these 5 points. For the voltage, if I wanted the voltage of R2, what do? I connect one wire of the DMM here and the other wire here. Also, don't forget to change, if I'm going to measure voltage, change the connection to voltage. And then what? Return first everything back. And then if you want to measure voltage, make sure to make the settings again for voltage. And then connect it in parallel with the elements. In parallel with the resistor like this. This is gonna give me what? The voltage of R3. If I connect it like this, it's gonna give me the voltage of R2. What if I connect it like this? What is it gonna give me? The voltmeter. It's not wrong. It's gonna give me a reading, but reading of what? Voltage of what? Yes, the sum of the voltage of R2 and R3, which is the same as connecting it here with R1. Okay? So this is the basics of implementation. If you understand today, the rest of the experiments are very, very, very easy for you.